Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's video, I'll be talking about Z-test. Z-test, as we know, is used to check the equality of column proportions. This video is divided into three parts. In the first part, I will be talking about custom tables. We will be performing an exploratory data analysis, wherein we will be showing how to obtain column proportions, as well as how we can visually depict the information in a useful graph. In part 2, we'll be performing testing of hypotheses, where I will be introducing Z-test. Z-test, as we all know, is used to check the equality of column proportions. And after using the Z-test for multiple pairwise comparisons, we will look at two important options in SPSS. One is called as the Bonferroni test, and the other one is what is called as the Benjamini-Hochberg test. The Benjamini-Hochberg test is available for those people who have SPSS 24.0 or a version which is greater than 24.0. And in the part 3, we will be looking at how we can summarize the results obtained in custom tables, how we can use the output for reporting and presentation. So this is what I have. Part 1, custom tables, EDA. Part 2 would be testing of hypothesis, wherein we'll be looking at Z-test. And after Z-test, we can look at Bonferroni test and Benjamini-Hochberg test. And finally, we'll be looking at how do we present the output of custom table. I will be working on SPSS to demonstrate some of these options. So this is the data set that I have. What you're seeing in front of you is SPSS. I've got two columns. The first one is education level of the customer. There are 5 different categories. As you can see here, the first person has obtained a college degree. Second customer has obtained a post-undergraduate degree. The third customer has, in fact, he did not complete high school. Fourth customer has a high school degree. You also see a second variable, which is called as churn. It is a flag variable. There are 2 outcomes, yes or no. What do we mean when we say churn? Churn refers to those customers who switch from one service to another service. Let's say you're using a particular network. You're not happy with the network provided by the service provider. You're not happy with the quality of the network. Let us say there are a lot of call drop issues. You are getting a very high bill every month. So you decide to switch from one network provider to another. That behavior is called as churn. If a customer has churned from one service to another, we are calling him as a churner. If a customer has not churned within the last month, we are calling him as a non-churner. I'm right now in the data view. Let me look at variable view. You can see here, education level is given and the different values are coded under the values column. Let me click on the end of the cell. The radio button pops up. And once I click on the radio button, a new dialog box pops up. When we look at the education level, you can see here there are 5 groups. Did not complete high school degree, some college degree, post-undergraduate degree. So these are the 5 levels. And when we look at the churn behavior, there are 2 categories, no and yes. So to summarize the information that we have got between these 2 variables, what I can do is I can look at the custom tables. Firstly, how do we access the custom tables in SPSS? We can click on the Analyze menu. From the top, the 4th option is Tables. Within Tables, you can see 3 different options. I will choose the very first item here, which is called as Custom Tables. Let me click on the Table option and choose the Reset option. I'll choose Reset and all tabs. So this is the interface of custom tables. You see the 2 variables in the data set that I have, namely education level and churn behavior, are displayed in the canvas on the left-hand side. You can also see what is called as columns and rows axis. I have to drag and drop the variables in the left-hand side to the row axis as well as to the column axis. What I will do now is drag the variable level of education to the row axis. You can see here the different categories of this variable are displayed under the categories description. Now, what about the column? Let me drag and drop the variable churn along the column. So I've got two categorical variables, namely level of education as well as column. And you can see here it says N, 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 and N, which means only the number will be displayed, not the percentages. Let me go ahead and report the information within this cross tabulation. One important piece of information is that I have got two categorical variables, one along the row and the other along the column. Let me click on OK. You can see here, SPSS displays the output. You can see some numbers appearing here. We are getting the breakdown of each levels of education level along the row, and along the column we are shown two different groups, no and yes. How do we interpret this number 172? 172 represents a number which simply says in this company you have 172 non-churners who did not complete high school. If you compare it with the number 32, it simply means there are 32 customers from the churn category who did not complete high school. So there are 32 churners who did not complete high school, but there are 172 non-churners who did not complete high school. So one is to look at the numbers, but better than looking at the numbers, we can display the percentages. The question is, how do we look at the percentages of each of these numbers? I can use the dialog recall option. The moment I click on the dialog recall, the first item here is custom tables. Let me click on custom tables, and you can see here, this is the options that we have specified for custom tables. We have numbers. I want to change this into percentages. How do I change this into percentages? Let me click on level of education. The moment I click on level of education, you can see here summary statistics tab gets highlighted. Let me click on summary statistics. A new interface opens up. And as you can see here, by default, SPSS gives us counter. When you look at the left-hand side, you see a variety of options, count, row percent, column percent, so on and so forth. There is an important piece of information which I'd like to give you. Before SPSS version 24.0, you had 47 test statistics. I repeat, you had only 47 test statistics. From SPSS 24.0, we have 167 test statistic options. So you have a big jump from 47 to 167 options. If you unclick on this plus button, you can see some of the new options like lower confidence limit for count, upper confidence limit for count, standard error for count, so on and so forth. Similarly, when you look at row percentage, you have row n percentage, lower confidence limit for row n percentage, upper confidence limit for row n percentage. You have a variety of options. It is not possible for me to cover all these options in one video, so please bear with me. Now, I don't need the count, I need the percent. So you can see here the third option that SPSS displays is column percent. Let me click on this option. The very first option here is column n percentage. I can click on the arrow. Now you can see column n percentage gets displayed. I will kick out the variable. I'll kick out the statistic count. Now I have got column n percentage. I'll say apply to selection and then close. You can see here now the percentages are displayed in each cell. Let me click on OK. You can see here now we can see the percentages. Please compare this with the earlier table. We only got the simple cross tabulation between the row and the column. Now what I have is percentages. It's always easier to interpret in terms of percentages. When you add the column total, you should be able to get 100. That is 23.7 plus 30 point something plus 20 point something plus 19 point something plus 5 should add up to 100%. Similarly, when you look at the second column total, that should also add to 100%. Now we have two numbers, that is 23.7% and 11.7%. How do we read this number? 23.7% is a very interesting number. This tells us the proportion of people who did not complete high school in column 1. 11.7% tells us the proportion of people who did not complete high school in column 2. And column 2 is churners, column 1 is non-churners. You can see here, no means non-churners, yes means churners. Let's look at 30.9. What does this mean? It represents the proportion of people who completed a high school degree in column 1, and 23.0 represents the proportion of people who did complete high school degree in the column 2, right? Proportion of people who completed a high school degree in column 1 versus the proportion of people who completed a high school degree, who got a high school degree in column 2. That's how we can interpret each and every number. Now, many times when we show a table, it becomes lengthy, it becomes tedious. We may not have the patience to interpret each and every number. Question is, can I turn this lifeless, dead table into a graph? Because graphs are appealing. People relate to graphs, not to numbers. How do I convert this dead table into a beautiful graph? To do that, let me double click on the table, right click. And once I right click, you can see the chart editor window opens up. You see what is called as create graph. We have 5 different options, namely bar chart, dot chart, line chart, area chart, and a pie chart. I will choose the option bar chart. And below the table, you can see a very, very informative bar chart. You see 2 sets of bars. To the left side, what you see is non-churners. Churn within last month is no. And to the right side, what you see is churners. And you see 5 different bars for non-churners. Similarly, you see 5 different bars for the churn category. What do these 5 lines correspond to? These 5 lines correspond to different levels of education. When you look at the non-churners, the red color bar stands out. And the red color bar, you can look at the legend here, represents those people who have a high school degree. So I can say that when you look at the non-churners, the majority category is of those people who have a high school degree. Let me now look at this set of churners, and I can see this guy here is the tallest bar. What does the legend say? The legend says a college degree. So the majority category amongst the churners would be the one that has a college degree. So this is as far as part 1, wherein we are doing custom table, percentages, and graphs. As part 2, what I would like to do is introduce Z test. Z test is very, very important because it is used to compare or check equality of column proportions. I repeat, it is used to check whether the proportion of people in one group is the same as the proportion of people in the second column. You're effectively going to check whether this number 23.7% is the same as 11.7%. Similarly, 30.9% is it the same as its neighboring number. So we have to do a pairwise comparison. How do we do a pairwise comparison? Using custom tables. Now, to do a pairwise comparison, I'll have to go back to custom tables. Let me open up custom tables. These are my old selections. I'm not going to make any changes here. Level of education is the same variable. Columns, I've got two categories. Now, to do a Z test, let me click on test statistics, which is right at the top. You can see the tab here. It says test statistics. Let me click on this option. There are a bunch of options here, and it's very easy to get lost when you look at so many options here. There are three tests which I'd like to draw your attention to. First is compare column means. I will not be doing this in this video. Second one is compare column proportions. This is what I will be interested in. So let me tick this option. I am interested in comparing the column proportions. The third test here is test of independence, for which you can use a chi-square test. I am ignoring the compare column means option as well as the test of independence through chi-square. I am interested in performing a Z test. I'm interested in comparing column proportions. Right below this, you see the significance level, and by default, it is 0.05. If you're using a SPSS version, which is lesser than 24th version, you see only one box where you can specify one significance level. I'd like to draw your attention to one big change that is available for SPSS 24.0 and all the subsequent versions. What is this big change? You can see here the next box as well, wherein you can specify an additional significance level. You anyway have 0.05. If you want, you can also specify 0.01. What is the use of this, you may ask me? The use is that we can run two tests simultaneously. Right? We can run two tests simultaneously. But I'll just ignore this for time being. I'm using a Z test to compare the column proportions. With this, you can also see some description. It says chi-square and column proportions test apply to tables in which categorical variables exist in both the rows and columns. Very, very important message. SPSS gives you an important piece of information, that is chi-square and column proportions test. I'm using a column proportions test. It says is applicable to tables in which categorical variables exist in both the rows and columns. If we go back to table, level of education is a categorical variable. The variable churn is also a categorical variable. So I have a categorical variable along the row. I also have a categorical variable along the column, which means I have a green signal as far as performing column proportions test is concerned. I can use a Z test. With this, let me click on the option OK. What do you see here? The heading is comparisons of column proportion. You can see here A and B. This is just a symbol for non-churners. A represents non-churners and B represents churners. Now we can see two different tables. This is the main table and this is the second table. The main table just gives the numbers, that is 23.7% and 11.7%. What we are doing here is we are comparing A column, that is the first column, with the B column, which is the second column. If there is a difference between A and B, SPSS will highlight by printing the second column symbol, which is B here. Wherever there is a difference between the pairs, that will be highlighted here as B. Is 23.7% significantly different from 11.7%? Yes, SPSS found it to be different, and therefore it is highlighting B here. Similarly, when you look at 30.9% with its neighboring number, there's a significant difference. Therefore, B is highlighted. Look at the numbers here. For some college, it is 20.7 and 21.5. They're very, very close to each other. There is not much of a difference. And therefore, you see a blank being returned by SPSS. So you don't see any letter at all. Now, compare 19.6 with that of 33.6. There is some gap that I see, and therefore A is printed here. Similarly, when you look at 5.2% and 10.2, again, there is a significant difference between these two proportions. Remember, what are we checking for? We are checking for a very, very simple and a straightforward equation. The proportion of people, let's look at the last row, the proportion of people who have a post-undergraduate degree in column 1, is it the same as the proportion of people who have a post-undergraduate degree in column 2? Is it the same? If it is the same, you can see a blank. If there is a difference, you see a letter B printed out. Now you can also look at the footnote here. What does SPSS say? Results are based on two-sided tests. For each significant pair, the key of the category. What is the key of the category? A is the key of non-churners and B represents the key of churners. Let me go ahead with the reading. For each significant pair, the key of the category with the smaller column proportion appears in the category with the larger column proportion. Significance level for upper case letters is 0.05. Very, very simply put, when you compare 23.7 and 11.7%, 11.7% is smaller than 23.7%. What is the key for this particular proportion? It is column B. Therefore, wherever you see a smaller number, that particular key is returned. Compare 30.9 and 23.0. 23.0 is smaller than 30.9, and therefore the corresponding key is B, which is printed here. Compare 33.6 and 19.6. 19.6 is smaller than 33.6, and therefore the corresponding key is written as A. So this is how we can do a comparison of column proportions. So here, as you can see, we obtain two different tables. One is the main table, which has only the percentages, and the second table wherein we have been able to make a comparison of the column proportions. Now, can we merge both these tables and get one table? Instead of having two different tables, can I obtain one table? How do I do that? Now, to do this, let me go back to custom tables. This is the earlier setting that I had chosen. And as you can see here, identify significant differences. The moment I clicked on compare column proportions, by default, the option that is selected is identify significant differences in a separate table. This is the option which was selected. And therefore, you can see at the background, you have two different tables. Now, instead of choosing in a separate table, we can choose the option display significance values, right? We can choose a significance value. Now, what is the change that we are able to see? Let me click on OK. You can see here, this is the latest output that I have. You can see here, along with the key in bracket, it also displays the significance level. So this is the p-value which is being displayed within the parenthesis. So 0.000 is nothing but the p-value. 0.014 is again the p-value. Each of these numbers are less than 0.05, 0.000 or 0.014, 0.000 again, and 0.005. Each of these numbers are less than 0.05, and therefore we can go ahead and claim that there's a significant difference in the proportion of people who did not complete a high school degree in column 1 vis-a-vis column 2. Now, again, as you can see, I'm getting two different tables. I want to just summarize this in one consolidated table. I don't need two different tables. Let me open up custom tables. As you can see here, I'm still in a separate table itself. I have clicked on this particular option in a separate table. Let me move on to in a main table. So this will do what? This will give me one consolidated table, and instead of having two separate tables, I can get the output in one single table. This is again one of the additional features in SPSS 24.0. Earlier, you did not have this particular option. Right below this, you have an option which is called as adjust p-values for multiple comparisons. By default, we had chosen the Bonferroni test. I repeat, by default, we had chosen the Bonferroni test. You can see here at the background, we have the description. Tests are adjusted for all pairwise comparisons within a row of each innermost subtable using the Bonferroni correction. Now, there is a big change. SPSS 24.0 gives us an alternative test, which is called as Benjamini-Hochberg test. I repeat, this is an alternative of Bonferroni test. It's called as Benjamini-Hochberg test. If you are using a SPSS version which is less than 23.0, you will not be able to see this option. You'll only be able to use Bonferroni test. Now, after SPSS 24.0, you have this additional feature of Benjamini-Hochberg test. One question is, which one do I use? Should I use the Bonferroni test or do I use the Benjamini-Hochberg test? Please remember, Benjamini-Hochberg test is less conservative than the Bonferroni test. I repeat, Benjamini-Hochberg test is less conservative than the Bonferroni test. So let me choose the Benjamini-Hochberg test. The earlier results that you obtained were using the Bonferroni test. Now I'll be using the Benjamini-Hochberg test. I've also chosen to identify the significant differences, not in a separate table, but in one consolidated main table, right? So let me click on OK at this stage. You can see here now, instead of obtaining two separate tables, you can visualize everything in one consolidated table. Let me scroll up. Please look at this. You have two separate tables. This is what you had earlier. Now that I have chosen one table, I'm able to see the percentages or the column proportions for each cell. And below, I can see the key as well. So wherever there is a significant difference, it is printing the letter with the smallest percentage. So this is very useful. I'd like to draw your attention to the third part. Let me take you back to the Word document. In the first part, we spoke about custom tables. How do we obtain the column proportion in the graph? In the second part, we spoke about testing of hypothesis, where we spoke about Z test. We made a comparison between Bonferroni and Benjamini-Hochberg test. And we said that Benjamini-Hochberg test is less conservative as compared to the Bonferroni test. And as part 3, we'll be now focusing on reporting and visualization. Let me go back to the output. Very, very interestingly, if I want to highlight those numbers where there is a significant value, how do I highlight it? Let me first double click on the chart so that the chart becomes active. Let me hover the mouse close to A. Now, when I hover the mouse close to A, you can see SPSS highlights all those cells which contain A. As you can see here, next to college degree and post undergraduate degree, 33.6% and 10.2%. Below this cell, you have A. So wherever you see this key value, SPSS highlights this. This is very, very easy because it helps me interpret the numbers a lot easily. Let me now hover the mouse close to B. What you see is SPSS again highlights those cells which contain the key value, namely B. Very, very interesting. This feature is present only in SPSS 24.0 and after 24.0. If I have to take this table and export it into PowerPoint or a Word document so that I can discuss this with my guide or with my boss, how do I do this, right? The moment I remove the mouse away from the key value, you can see the color coding also vanishes. But I want the color coding to stay for both these key values. How do I do this? One thing that I can do at this stage is double click and simply right click on the table. Once you right click, you can see there's an option which is called as select. Can I see the option select? I'm not able to see this. Okay, let me double click again. Let me come here, point towards A, double click, sorry, right click. And once I right click, you will be able to see the option select. So within select, you can see a bunch of options. What I will do is select all cells with this significance key. I'm going to choose the last option, namely select all those cells with this significance key. So what SPSS does is it selects A. All those cells which contain A here, that will be selected. There's an additional thing which I would like to do, that is right click on this. And once I right click on this, I will choose the cell properties. Once I choose the cell properties, here I can change the text color as well as the background. The background I'm happy with blue. And when it comes to, the text color is blue. When it comes to background, let me change it to a different color and simply apply and say, okay. You can see here, this is how it appears. I can do something similar for B here. I'm double clicking on this, pointing the mouse closer to B. Let me right click on B. Now I'll choose the option select. I'm going to select all cells with this significance key. Let me click on the last option. So now SPSS selects all those cells which contain B. Right click on this and you can access the cell properties. Again, I would like to change the text color as well as the background. Here, let me choose a background of, let's say, red, if this is very, very important. And when it comes to text color, I can use green or any other color. Let me click on apply and choose OK. So this is how it appears. Now you can just copy paste this particular table into PowerPoint or Excel, and you can easily explain some of these numbers. You can also tell the audience as to why have you highlighted certain cells in red And why have you highlighted certain cells in yellow? Yellow because some of these are cells which contain A, and some of these cells contain B. One point which I'd like to call out here is, when we open up custom tables, when we say multiple comparisons, now this is very, very useful. Which test am I talking about? Let me go to test statistic and show you Benjamini-Hochberg test. It says this is used for multiple comparisons. Let me show the table. Here I've got only 2 columns. Many times if you have more than 2 columns, like 5 or 6, then this particular multiple comparison test becomes very, very useful, because it helps us identify which is the significance key, because it appears right below the percentage number. So this is what I had in today's presentation. Let me just quickly summarize what have we spoken about in today's discussion. We looked at custom tables. We did an EDA, exploratory data analysis. I showed you custom tables, column proportions, how we can quickly convert the table into a graph. Then we moved on to testing of hypotheses. We looked at Z-test. Z-test is used to check equality of column proportions. And when you want to do multiple comparisons, you can use either the Bonferroni test or the Benjamini-Hochberg test. Benjamini-Hochberg test is less conservative than the Bonferroni test. And finally, we looked at certain features which helps us in reporting and presentation. If you have liked this video, I request you to subscribe to my channel. I request you to hit the subscribe button. Please share this video with your friends and relatives. Thank you very much. Have a great day.